Okay, so I'm going to show you how Blackfire can help you um, debug and detect outstanding SQL requests and everything that's bound to the SQL request. This shouldn't be long. This shouldn't last very long. I just want to show you a few tips, hints if you use Blackfire. So now I'm going to share my screen. All right. So here I go again with this application, the Sasquatch sightings. So it's all about Bigfoot, and so just a demo application we're using. So first, well, we wanted to check with a profile because we detected that we had a problem. So let's do this. It's actually on production. So here is it's actually hosted on Symphony Cloud. All right. So we can see that, well, we have 50 SQL requests here. So this is our SQL dimension database dimensions that will complement all the other dimensions. So let's have a look. Okay, so once we're here, well, there is a lot to check here, and we can see, well, first in the left, on the left, the PDO statement that can give us hints, and yeah, if I click here, I can see that it contributes to the SQL metric, so that might be useful in the future for subsequent testing. Well, it's obviously consuming bandwidth since it's communicating with the database server, so that's perfectly expected. It's 240 kilobytes. That might be a lot, actually, for SQL results from the database. And yeah, let's have a quick look here. On this dimension, well, we can see that, yes, we had 50 requests and everything took almost 20 milliseconds. That might be a problem. Here, this part gives you interesting information about also the database connection. So, well, it's 1.1 milliseconds. That's not that slow. It might be lower. Generally, it's less than 1 millisecond. And we can also have this very useful information. It's about ORM entities, or entities or models. If you're used to Eloquent, we're talking about models. So if you have a lot of objects, model objects that are instantiated by Eloquent, or if you're using Doctrine, like this is the case here, they will be counted and reported here. So we can see that, yes, we definitely have a problem with ORM entities. So this is a first sight. We didn't browse anything. It just gives us a hint that we definitely need to fix something. And actually, if you go to the recommendations tab, this also should appear, like here. Less ORM entities should be created. So if I click on the help, well, here I have examples with Doctrine. I think we do not yet have examples for Eloquence, because it's usually bound to relationships, N+1 issues. So, but first, let's click on the View Details link. So here, this panel shows you all the database, all the SQL queries that were used by your application only on this page. And we can actually see that, well, we have two of them that actually consume quite a bit of time. The first one, well, should be negligible since it's only 341 microseconds. And for this one is most likely to select the article. So this is what we call a citing. Our website is showing articles reporting sightings of the Bigfoot in America. And here, this one is most likely to load all the comments here to report to load all of them. So yeah, it was quite fast actually. The two other one, well, we don't have that many clues, but we can see that for each for most likely for each comment, we also have users. They seem to be bound together. We don't have this information yet. We need to dig a bit. That's what we're going to do. But what I know about my application is that it's for each comment here. Well, we are at least loading the owner of the comment, so the user who wrote it. So that makes sense that we load this information, to load the model, the user entity, the user model. So, but yeah, maybe we should have a look at and know where my SQL query is coming from, because this is usually a question that we're wondering. Another interesting part here is that you can see that we don't have the column names. Well, this is actually part because of the anonymization process, which is done by the agent. So I remember that if I let me load this diagram showing the Blackfire stack. So, okay. All right, this one. We have two main components that need to be installed in order to be able to profile. So first is the probe, which gathers all the measurements, and the second one is the agent. And the role of the agent is to aggregate, do all the average thing, but also to anonymize. And by anonymization, we mean anonymizing SQL queries and external HTTP requests, because we don't have to know about it. By default, the SQL queries are actually arguments that are passed to the PDO execute function. So we don't have any access to the user data, to your data. And by default, your agent on your side, on your infrastructure, anonymizes the SQL queries to give even less information and sharing to the Blackfire servers. So that's why you don't have all the column names, and why you don't have the parameters either. And anyway, the parameters, as we're talking about SQL prepared statements, they wouldn't appear here. This is anyway a limitation and a security limitation from PDO. So this is the first thing. Maybe at some point we will need this, and I will show you how to display the whole query for this. But one of the things that we usually wonder is, how can I know where my request, my SQL request, is coming from within my application stream? Because I need to know exactly where in my call graph it has been triggered so that I can fix maybe something in my code. So this is so the very simple trick here is that I will just select my SQL query, and I just need to paste it here. And that's it. You can see that in the execute statement, it's actually, as I said before, the SQL query is an argument of the execute statement from PDO, and this argument is being captured by Blackfire, by the probe, so that each statement, each executed statement is independent. So if you have like 10 different SQL queries, you will have 10 different PDO statement execute calls displayed here. Okay, found the PDO statement execute, but I want it to be displayed on the graph. So the only thing I need to know is to click here to center the call graph on this node. Click in there, and now I know that, well, okay, it's coming from here. So let's zoom out a bit, and we can see that, well, this is dball, this is persistent collection from the ORM, and oh, this is from us. So we actually found where the function which triggers the SQL queries, the different SQL queries. So now we will be able to look into the code and maybe fix everything. So we know that we have an n+1. I won't show the code here because it wouldn't be quite relevant anyway. So, and if I wanted to check the other one, well, I can do the same, right? And I can repeat this. That will probably lead to the same node anyway. That's right. While maybe this one would be much earlier in the call graph. Oh, okay, it's even so that's actually interesting. Why don't we have any function call reporting this SQL query? Well, it's again about the agent, and so I told you that the agent has 3 different roles. The first one, the most important for you, is that it anonymizes sensitive data. It also aggregates the different samples that's been so that you can have a consistent profile, but also it prunes, aka removes function calls from the profile. The function, and it will remove function calls that are considered insignificant. It means that function calls that represent less than 1% of the overall resource consumption. And this is actually the case here, because I took this one. It was less than 1 millisecond. It was 753 microseconds. So this call had been pruned by the agent. And the same would go to this one. We can check, but I'm pretty sure this is the case. Yes. All right. So in order to get the information, we can actually do something, and using we will be able to use the debug add-on just in a minute. Before going to that, I wanted to show you. Remember, so the PDO statement executes here. There were parts of SQL.PDO queries, SQL queries, and SQL metric. So what I can do is just type the SQL keyword here, so that would make appear the different function names which are parts of the of this metric. Well, this maybe I should do SQL.queries. So actually, we have 3 Oh, that's interesting as well, because this is the one we were looking for, and it didn't appear. Okay, maybe I can check again and just select. No, it was this one. Okay, just part of it. You can even search with part of it. Oh, it's the same. Okay, well, that's let's call it the demo effect. So if you type just SQL.queries, you will make appear, well, filter out the lists of the function calls to make appear only the one that are actually relevant. Okay, so last thing I wanted to show, because I talked about missing columns here, missing fields, and also missing SQL statements. So what I'm going to show you is how we can use this debug add-on. So the debug add-on, well, it's several separate subscription. You need to subscribe to the debug add-on in addition to your regular Blackfire subscription. I just click here, so it will disables pruning and anonymization. That is exactly what I told you. So let's click, and then it also disables the aggregation. So it means that it will take only one sample instead of 10. Let's click on it. Okay. And let's see the call graph. Now it takes longer because, as you can see, it's much more extensive. We have a lot more information here in the call graph, and this is precisely why we don't activate the debug by default. It's because you will have a lot of information and a lot of noise. So unless you exactly know what you're looking for, you may be completely lost in this kind of graph. So that's why we're pruning insignificant calls, so that you can have a visualizable graph, and so that is quite easier to understand than the whole thing. So let's click now on the SQL queries again. And now you can see that we have everything. The only thing that is missing is the parameters, because as I told just before, this is a security limitation from PDO statement. This is the prepared statements are here to avoid, mainly to avoid SQL injection. So you actually the parameters are injected after the execute call, because you just bind to, afterwards. But now you have the whole SQL queries that are available. Just click here to make it appear completely. So it can be useful if you need to understand from the database server why your request is so slow. Maybe, well, these ones are very quite fast, but imagine a very big query with subqueries and stuff like that. At some point, you may need to run explain statements on your database server if you're using MariaDB or MySQL, so that it MySQL or MariaDB, the database server explains you what is going on with this request. Maybe it's missing an index. It's usually always about indexes, right? So, and how you can optimize. This cannot be told by a profiler like Blackfire, because it analyzes your application data, your PHP, not application data, application code. it analyzes your the behavior of your application. So it's deep installed into your PHP engine, not within your database server. For this, you need to ask your database server why your SQL request is so slow. And this is precisely why we have this add-on to enable us to have the whole SQL query. And it's always an opt-in. So you cannot say by default, I want to always run debug. It will never be the case, because otherwise it will jeopardize the anonymization process. Right, and remember that here we have less than 200 microseconds, but having it completely here, we will probably be able to find the appropriate function call, which is very fast here. Okay, paste. All right, now we have it, and we even have the prepare connection. So this one was completely we couldn't see it before because it was way too fast. Well, if I check here, so look for prepare, I won't be anything here. But with the debug add-on, it wasn't pruned, so it does appear here. Okay, so that's basically it. A few tricks to help you debug your application and analyze your SQL requests. With this, you will be able to find outstanding requests and understand where they come from and why you have so many issues with this or that SQL request from within your codes. And well, if you have any question, well, feel free to ask. And thank you for attending.